Hello and welcome. I'd like to spend a few minutes today talking about the strength of materials. So the strength of material is pretty similar to probably what you think of as strength. It's really the ability to hold or support a load. And more than talk about what it is, I'd like to talk a little about how we determine it and how we use the strength of a material. So to keep this simple, let's think about a string suspended between 2 points. And what we're going to do is we're going to take and measure the length of that string. I'm going to call that x, and we're going to apply a force to it, pulling it apart, and I'm going to call that F. And now I'm going to create a graph where we're just going to plot the force in that string as we increase that length x. So we say we have x here on the x-axis in inches, and we have the force here on the y-axis in pounds. Let's say pounds force, just to be clear. And so here at the initial point here, we'll start at, say, 10 inches long, and then we'll have some increments out here. And then usually these changes in length are pretty small, so you might say this is 10.1, 10.2, 10.3, and then 4, 5, 6, 7, 8. And so we'll say this is 10.8. Right? And then on the y-axis here, we have units of pounds. And again, this is an example, so I don't really care how much these are, but we'll say 2, 4, 6, 8, 10. All right, so as we pull this string and make it get longer, the force is going to increase. Then at some point that string is going to break. So if it breaks here, say at 10 pounds, we can say the strength of the string is equal to 10 pounds. Let's get a little more specific here. When we think about this is 10 pounds, so this is 10 pounds per string. And this may seem like a simple difference, but it really does make a big difference in terms of engineering, because here we're saying that the strength is 10 pounds as a property of the string. So if we were to have 2 strings, we could have the ability to support 20 pounds, and 3 strings would be 30 pounds, and so on and so forth. And this becomes really useful because I can say if I specify a load that I need to support, so say I have a load here, and say that load that I want to support is equal to 100 pounds. Right? If I divide that load by the strength of what it is I want to support the load with, in this case we have 10 pounds per string, and this is the same as multiplying by the reciprocal, right? So we could say 100 pounds times the inverse of the strength. So we say 1 string per 10 pounds of force. Right, and then here if we look at the units for pounds force will cancel. We can get rid of one of the zeros to cancel the 10, and we get 10 strings. 10 strings. Which may be somewhat obvious to some of you, because if I say if it's 10 pounds per string, well then if I have 10 strings, 10 times 10, that's 100 pounds, right? And if we wanted to support 100 pound force, we might actually use 11 or 12 strings. The amount that we can hold is actually more than what we need to hold, and that would be what we call a factor of safety. We'll talk more about that in another video. But we can get even more specific when this, because this is still discrete, right? So we're still looking at strength as a function of the number of strings. Well, if we think about any material, for instance, if we have this string, look at it in more detail, we could say that the string is really just a cylinder. So if I'm thinking this is a section of the string. And then that 10 pounds of force, as it's distributed inside that cylinder, is even across its area. So think about the force being evenly distributed across the cross-sectional area of that string cylinder cross section. So here you say the force divided by the area, and this is what we call the stress. Right? And we often denote this with the lowercase sigma. Right? So if we take the force at failure, the 10 pounds, and we divide that by the cross-sectional area, and just for simplicity, let's say that cross-section area is 1 square inch. So we have 1 inch squared. That's going to be equal to 10 psi, or pounds per square inch. You see this pound force is over inches squared. So this is the strength of failure of that material. So I can say this is the ultimate strength. Again, that little U indicates that that's the ultimate or the maximum of stress that that material can support. So this is a little bit more continuous than the previous one here. So say this, we can only change the strength of an assembly by changing the number of strings, but in this one we could change the cross-sectional area of this cylinder to make the force that we need to support as large or as small as we want. So in this way, we're able to design any number of objects to support appropriate loads. And that's really what we want to do as engineers looking at the strength of a material. Thanks for watching.